All right. Next in our series of breaking down the most commonly confusing and conceptually difficult topics in GIS, we're going to talk a little bit about scale and generalization and what that means in GIS. Excuse me. That's me, Dr. Michael Harmon. I'm standing in front of Woodburn Hall. There's my contact information and a link to our website. Should you have any questions about anything related to the geology and geography department at Western University, check the website out. When we talk about scale and generalization, it's easy to get these things overlapped in our mind, and we'll kind of use them sometimes interchangeably. But in reality, we should, as they used to say, we should toss these nickels around like they're manhole covers. In other words, we should be much more careful about what we call what. When we're thinking about scale, we're generally thinking about how much we're zoomed in or out. And students often believe that zooming in on a map makes it large scale and more detailed. They don't always connect scale to what it really is, which is the ratio of the distance on the map and the distance in the real world. And the other concept that they have trouble with is not realizing that, well, data has to be generalized. So, like I said, they zoom in, they think, well, there's got to be more detail because I've zoomed in. What they don't realize is that the data set itself only has the detail it was collected with. So once you generate data like this, you collect it at a specific scale, and you cannot make that data any more finer than what it is. You can make it more coarse, but you really can't make it more detailed. And what happens a lot of times is students simply miss that when we talk about generalization, we're talking about simplifying features. And this is necessary for small scale maps if they're going to actually be readable. Now, again, think for a second. What is a small scale map? Small scale, big area. Large scale, small area. So when we're looking at a small scale map, that means a very tiny fraction in terms of distance on map divided by distance in the real world. A really small number. And so when we do that, if we want to be able to see things, we have to generalize stuff. If we assume that features are exact, and they may believe that line and polygon boundaries are exact representations of reality, not general approximations that vary with scale, but that's really not the truth. Um, they do vary with scale a lot, and these boundaries are as exact as we can make them, but nonetheless, they are still generalizations, approximations. Scale tells you how much real world area one unit on a map represents. Large scale, small area. Small scale means it's a large area. Scale is basically the translator between real world and the map. It tells you how much stuff you've squeezed into that page. Large scale is like a close-up photo. You see lots of detail, but only for a small area. Small scale maps is like a selfie from outer space. You see a huge area, but only the big stuff really is there that you can see. Scale is just about isn't just about zooming in or out. It's about the level of detail your data can support. Uh, and so using data at the wrong scale is like trying to read street names on the globe. The information just isn't there. So if you collect data at one scale, for example, uh, looking at a small area, so if we look at a large scale map and then we want to zoom that really in and make it more of a small scale map, the extra detail that you get from zooming in is just going to be the same information that you had before. What is generalization? Well, it's where lines get smoothed, small features disappear, and shapes become more schematic. You can't fit reality into a GIS. The world's a big place, and there's a heck of a lot of it. And when you try to put a heck of a lot of something into um, a very finite space, it just won't fit. So you can't draw every leaf on every tree. You just have to make an outline around the forest. You have to try to fit in any part of everything in a GIS. You're bound to have to simplify aspects of that physical representation. There's an old adage about how far is it along the coast from Miami to New York City. And the answer is it depends on the scale you measure. If you're at a very coarse scale, you get one number. And as that scale gets more finer in detail, you pick up more ins and outs along the shoreline, and that number gets larger and larger and larger. And then ultimately, it's probably going to get close to something that's going to be an awful lot like infinity. Not exactly infinity, but an excruciatingly long number. Because if you go into enough detail, you're literally going to be chasing the boundary of the ocean around every grain of sand along the beach. And so that's, you come to a grain of sand, you go out around the grain of sand, back around the grain of sand, over to the next grain of sand, out around the grain of sand. You get the idea. If you start making all those tiny little curves, that distance is going to become just astronomical. Generalization is the art of simplifying the messy, detailed world so it can fit into a map without turning into a tangled mess. At small scales, you can draw everything, every driveway, every stream, every tree. Cartographers smooth lines. They remove tiny features. They merge small stuff into bigger things. The goal isn't to lie, but to keep the map readable and meaningful. Generalization is why a river might look curvy on a city map, but almost straight on a world map. Same river, it's just simplified to match the scale. So I hope that helped clear those topics up. And if you're thinking about advancing your geospatial knowledge, you want to learn more, you want to get a master's, Western University has a fully online, fully asynchronous, affordable master's degree that is nationally recognized and available to students from, well, around the world. We do virtual information sessions if you want to learn more about it. Check out this web link here, this address. This will take you to the page for the online masters in GIS and spatial analysis at WVU. And then scroll around that page there, you'll find the spot there to register for the information sessions. We typically do 3 in the fall, 3 in the spring, and a couple in the summer. And so there's always one coming up, and there's plenty of opportunity there to learn more about the degree program and to ask questions. All right, that's it. I gotta keep this on here for like 5 seconds so that you can have the option of watching another video from my channel or subscribing if you like.